Okay, this is the last chapter, excuse me, the last lesson in chapter 3, not the last chapter. Last lesson in chapter 3, graphing linear functions, which you probably think we have been graphing linear functions, which we have been. This should be not a whole lot new, just another way of representing it. It's called function notation. Okay? We have seen linear functions written in the form y equals mx plus b. By naming a function f or g or h, you'll see all of those, you can write it in what's called function notation. The symbol f of x, or f parentheses x, is just another name for y. Okay, when you see f of x, it's put into the place of y, and I will show you. And we read it f of x. So this is something you need to remember. So if you want to underline it, you could underline this right now, f of x, and it means a function of x. So in other words, f of x is a function of x. This y, or f of x, is a function of x. Okay, and the main idea I want you to take away from this is f of x and y are synonymous. I can say f of x or I can say y. It's just something that you're going to see and you need to be familiar with. I can interchange these and they should mean the same thing. Okay, f of x equals mx plus b is the same as y equals mx plus b. Okay, because the f of x represents my y. And if you want to, we could write it like this. F of x equals y. Okay, moving on. So what is the value of the function f of x equals 3 times x minus 15 when x equals negative 3? All we're doing is we're going to substitute, well, write the original function. So on your paper, I think it's already written. Maybe it's not. Go ahead and write it. And then substitute the negative 3 in for x. Now notice they substitute it in both places. They don't say that y is negative 3. They're putting it in for the x. Okay, so f of negative 3, or in other words, y, equals 3 times negative 3 minus 15. So whatever value you see inside the parentheses, if you do, is going to be your x value. The entire quantity f of x represents y. But inside the parentheses, since x is in the parentheses, if you see a number in the parentheses, that'll be your x value that you put in for x to solve. So as we solve this, 3 times negative 3 is negative 9, and then negative 9 minus 15 is negative 24. So f of negative 3 equals 24. I want to see if it says that. Okay, so let's go ahead and write that on your paper. Write f of negative 3 equals negative 24. And since we said that f of x, or f of our value, equals y, we can also write y equals negative 24. And that makes sense. Okay? Because this entire thing is our y. This is our x. This entire thing is the y. All right. For the function f of x equals 2x minus 10, find the value of x so that f of x equals 6. Okay, so in other words, since f of x, or y, equals 6, we are going to substitute 6 in the place of the f of x and then solve for x, because that's what we're looking for. Find the value of x. So obviously we need to solve for x. So here we go. F of x is in red because that is what we are going to change. Our f of x equals 6. It is what we know. The x is what we don't know. So we put our 6 in for f of x, and we get 6 equals 2x minus 10, and then we solve and we get 8. Okay, add 10 to both sides, we get 16, just for those of you that are still kind of iffy. Okay, we get 2x equals 16, and obviously if 2x is 16, 1x has to be 8. Okay, so when x is 8, f of x equals 6, or y equals 6. When x is 8, y is 6. All right, I know it's a lot of words, I'm sorry, but it's pretty simple. The gray wolf population in central Idaho was monitored over several years for a project aimed at boosting the number of wolves. They wanted to increase them. The number of wolves can be modeled by the function f of x equals 37x plus 7, where x is the number of years since 1995, the number of years since 1995. So 1996 would be 1, where x would equal 1. 1995 would be 0. X would equal 0 because there's no years since 1995. So we're going to graph the function and identify its domain and range. Okay, so to graph the function, make a table. That's on your chart, on your notes, excuse me, this table right here. So this right here, outside of your table, please write 1995. There were no years since, so there were probably about 7 wolves, because 37 times 0 is 0 plus 7. This would be 1996, and this would be 1997, just so that you can understand where we're getting our x values from. Okay, now, there's our table. So when x is 0, y is 7. Notice they're counting by 20s. So we're right about here for 7. In the 1 year after 1995, we were up to 44 wolves, so we're about here. And then 2 years after, we're at about 81 wolves, and so on. We're increasing by 37 wolves each year. Okay? Now, the domain. The domain of the function is x is greater than or equal to 0. Why does it have to be only positive numbers? Why can x not be negative numbers? The main reason is years since 1995, we're not looking at any years before 1995, so we're not going to go into the negatives. Plus, we can't go into negative wolves. Okay? And from the graph or table, you can see that the range, or the y values, right here, we start at 7 on the y-axis, and we go up into the positive y. So it has to be greater than or equal to 7. And the wolves are not decreasing, the wolves are increasing, so that makes sense. And obviously our x starts at 0 because we had 0 years. So that's your domain and range. What x and y values does your table or your graph show, and what values make sense for that domain and range? Okay. All right, this is our last example. Graph the function and compare the graph with the graph y equals x, or f of x equals x, which is the same thing as y equals x, just FYI. Keep that in mind. Okay, so here's our function, g of x, because we don't want to call it f of x, so this one we're going to call g of x, showing that we are representing 2 different functions. Don't let it throw you. This is still y right here. Okay, g of x is also y. We're just demonstrating that there's 2 separate functions going on. So here's our graph. Y equals x plus 3, or g of x equals x plus 3. So here is my graph of the blue one, f of x equals x. Notice 0, 0, 1, 1, 2, 2. What do you notice? Whatever x is, y is. Does that make sense? Because y equals x. So if x is 1, y is 1. If x is 2, y is 2. If x is negative 4, y is negative 4. So that's our graph of f of x equals x. And you need to star this because you will be using this a lot in your assignment, on your test, and in your study guide. Okay? All right, so here's our next graph. Let's look at our graph. We can just use our slope-intercept form. Our y-intercept is positive 3, so we graph it at positive 3. It's where we start. Okay? And our slope is just 1, or 1 over 1. Notice the graph, we can't really go up and over. We could for one point. So instead of going positive y, positive x, let's go negative y, negative x, and plot a point, negative y, negative x, plot a point, negative y, negative x, plot a point. Okay? So draw our line. And let's look at how they compare. This is what you're going to be expected, a similar answer on your guided practice. Because the graphs of G and F have the same slope, they do. They both have a slope of 1. the lines are parallel. That's one comparison. Okay. Also, the y-intercept of the graph of G is 3 more than the y-intercept of the graph of F. That's it. That's your comparison. Comparing the y-intercepts and comparing the slopes. Okay? All right, so let's look at another example of this. So let's do the same thing. We're going to compare this one to f of x equals x, or y equals x. Okay? So let's graph this. And here's our blue one, f of x equals x. Again, we have 0, 0, 1, 1, 2, 2, 3, 3. So again, star that because you're going to use it a lot. And here's our 2x, or h of x equals 2x. My y-intercept is nothing. This is a direct variation. So my origin is the same, or my y-intercept is the same, but my slope is quite different. My slope is 2 over 1, so I go up 2 and to the right 1, and then up 2 and to the right 1. I can also go negative 2 and to the left 1. Okay, so I can go positive, positive, or negative, negative. So here again, here is an example of what a good comparison answer looks like. This is what I am expecting when it wants you to compare the graphs of the equations. Because the slope of the graph of h is greater, because 2 is greater than 1, okay? Since the slope of the graph of h is greater than the slope of the graph of f, the graph of h rises faster from left to right. It's more steep, okay? The y-intercept for both graphs is 0, so they both pass through the origin. They are both direct variations because they both pass through the origin. So just some good comparisons of what we notice about the two lines. So those are the kind of things I want you to look for when it asks you to compare. Okay? All right, you can stop the video. That's it. We'll see you in class tomorrow.